This is Professor Pelton. This is Trigonometry Chapter 3, Section 1. This is Part 2 of 2. We're going to cover bearing here. Some books cover bearing, some books cover heading, some books cover both bearing and heading. We're just going to do bearing in here. Bearing is used by the U.S. Army in this country that defines which is defined by a point O to a point B as the angle between the ray in the direction of north-south, whose origin is point O, and ray OP. The bearing consists of two characteristics in one number. The first characteristic is the north-south characteristic, followed by the angle, which is acute, and the second characteristic is the direction, which is the east-west. So typically when you read a compass, you do not need the east-west. There's only a north-south spinning line, so that is all you need in a compass, is the north-south line that spins. So if I was going to do the bearing here, this would be north by 40 degrees east would be my bearing. And here, likewise, is south by 20 degrees west would be my bearing. Okay, and basically you can ignore east-west lines. Are not really critical to be able to read bearing, really. Okay, pause the video, try these student problems. Okay, for the student problems, we have north by 65 degrees west. Looking at the north-south line. North-south line again. We have south by 70 degrees east. And the third one is actually a heading of 225 degrees from north, but we only want the bearing in these problems, so we only want this angle right here, which is 45 degrees once you take out the 180 degrees half turn. So this is actually a south by 45 degrees west for a bearing. Okay, let's try some more examples. So typically bearing problems will be given in terms of a point A to point B, or in this case from a center O to other points such as A, B, and C. So in this case, if I go to A from O, that's north by 30 degrees east. If I go from O to B, that's north by 60 degrees west. And finally, O to C is south by 70 degrees east. And D is south by 80 degrees west. In each of these examples, all I needed was my north-south line. Essentially, the east-west line is not needed because you only read a north-south line that spins in a compass. Pause the video, try these student problems. Alright, O to A. So I go O to A. A is right here, but the problem is I only need my north-south line. So the correct angle is actually 70 degrees from the north-south line. So that's north by 70 degrees east. O to B from the north-south line is north by 40 degrees west. Okay, next one, O to C. Going from the north-south line, I have that little angle of 15 degrees since it's 90 all the way around there. So that's south by 15 degrees west. And finally, the last one, going to D, is south by 25 degrees east. Okay, so that's the intro to bearing. Let's try some example problems now using bearing. Okay, so I gave you a diagram here, but typically a diagram will not be given. So when you read these problems, all you need to look at is the distances and the bearings. The rest of the information is irrelevant until you get to the solving part. So you should always start with some kind of point somewhere in the middle of your paper and name that point. Since we're starting at the harbor, we'll name this H. And then draw a north-south compass from that point. Okay? So from that point, using the compass, we can draw the direction. So our direction is north by 42 degrees east. So draw it longer than it needs to be. That's north by 42 east. And then don't put an arrow on it. Put another point. That'll be some point in the water somewhere. And we'll draw another north-south compass. And again, don't draw the north-south compasses too big. Draw them kind of small, but draw the vectors long. So from that point, we're going to go another turn of south by 48 degrees east. So south by east is going this way. Again, draw it longer than it needs to be. and that's 48 degrees. Now we're at some other point out in the water, but now our boat has stopped. Our engine died. All right, so we'll call that the boat right there. So we want to know from the harbor to get to the boat. We want to know that distance, and we want to know the bearing to get there. Okay, so let's put our distances in the problem. So the distances given were originally the 25 miles was first. So 25 miles is first. And then the 18 miles was second. Okay, so since this is a triangle, we are missing one more side here. But the question is, what kind of triangle is this? Well, every compass is parallel, right? As a result, these are alternate interior angles, so they are congruent. So that is a right angle, since 42 plus 48 is 90 degrees. So this is the right triangle, so we can use Pythagorean theorem. So d squared equals 25 squared plus 18 squared. So d equals the square root of 625. Let's see, it's 324. Technically it's plus minus, but we only want the positive answer in this case. So d equals the square root of 949, which is not a perfect square. So d is approximately 30, sorry, let me scratch that off, 0.8 miles. So approximately 30.8 miles. Okay, so now we need the angle here. But the problem is with the angle is we cannot use an approximate side because that would throw our angle off by several degrees. We don't want to do that. So we should only use the exact measurements that we already have, which is the 25 and the 18. So if I do that, that's the opposite and adjacent, which is the tangent of the angle. So the tangent of the angle is the ratio of opposite over adjacent. So if I inverse tan both sides, that will cancel the tangents there, and that will leave me with a theta. And again, when you put this in the calculator, make sure you put it in degree mode because we want a degree answer. You can put either one, but we specifically want a degree answer in this case. So that gives us about 35.75 degrees. So that's about 35.75 degrees. However, we need to put our answer in terms of a bearing. And our bearing is not 35.75 degrees. It's going to be this entire angle from north. Okay, so we actually want to add those together. So we get a north by 77.75 degrees going to the east. That is our bearing when you add those two together. Okay, one thing to be mindful of is if that angle is more than 90 degrees, you are no longer going north. If you're going more than 90 degrees, right? If you go more than 90 degrees, now you're in fact going south. So keep that in mind, that you can't just simply add them together. You have to make sure they don't go above 90 degrees. So we have our distance, and we have our bearing to go find our sinking boat. So that's question A. That is question B. All right, pause the video. Try the student problem. Okay, same thing again. Draw a point somewhere on your paper and name that point. So we're going to leave a ranger station, so I'm going to call that R. I'm going to draw a north-south compass. Don't draw it too big. And then we need our next bearing. So our bearing here is south by 31 west. So if I go south by 31 west, that's this way. Make it longer than it needs to be. So that's 31 degrees. Alright, so let's do a little bit of erasing here and fix this up a little bit. So we don't need any arrowhead on this. That's going to be a point. Make this a little bit better too. Okay, so that's going to be like that. And south, this is a new point. So we're in somewhere in the forest. So I guess we'll just cover that, count that as F, I guess. Make another north-south compass. North, south. And then the question is, where do we go now? So now we go north by west. If I go north by west, that's this way. And that's going to be north by 59 degrees. So 59 degrees in that little angle right there. And that is where we stop. We break our leg now. We're in the woods, we broke our leg. And what is this spot? Who is this person? This is the hiker. So we're going to call that H. Okay, let's change colors. So we want to go from the ranger station to the hiker. So we're going to go that way right there. So we put our distances in. The first distance was 2.3 miles. And the second distance is 3.5 miles. And what we know is every compass, the north-south doesn't change, so they're parallel. So as a result, that is alternate interior to this. So that's 31 degrees. 31 plus 59 gives me a 90-degree angle. So I, in fact, have a right triangle. So I can find out my distance. Okay, so my distance, c squared equals 3.5 squared plus 2.3 squared. So c equals the square root of 12.25 plus 5.29. So c is equal to the square root of 17.54. So c is approximately 4.2 miles. That is our distance. Okay, so now we need the angle. But we should not use the angle from the approximate side. We should use the exact measurements we have, which is the 3.5 and the 2.3, which are the opposite and adjacent sides. So that's tangent. So tangent of the missing angle that we want is 3.5 over 2.3. So to inverse tan to both sides, inverse tangent of tangent. So cancel, cancel. So our angle, again, make sure it's in degree mode here because we want a degree answer. You can have it in radian mode if you want. You just have to convert it afterwards. We'll get about 56.7 degrees for this angle here. But that is not our bearing. Our bearing comes from the north-south line, which means I'm going this far here. So if I add those together, that's going to be 87.7 degrees. Since that is not more than 90, that means I'm still going south. So that's south by west. So if you're going more than 90 degrees, then you need to be going north by west. Okay, you have to convert to a acute angle. All right, that is the end of part 2.